Hello and welcome. I am Gingerbill, and today I'll be talking about the fiasco that has happened between Casey Muratori and Mr. Robert C. Martin. But before I'm going to explain why the history got here, and I'm going to also explain some stuff. I'm not going to try and criticize clean code itself. Casey Muratori has been trying to do this in the long discussions he's had with Mr. Robert C. Martin already, but it's one of those things where I just want to kind of show the rhetoric tricks of Mr. Robert C. Martin himself. So before we get to there, to start off, let's begin with the thing that started it all, which was this video that Casey made public from his thing. It's called Clean Code Horrible Performance, where it's a 22 minutes long video, him showing the examples of what clean code is, then going into a more, let's say, more like simplified code, which is more optimized performance, and showing the cost. Hey, if you do it the clean code where you're going to be 15 to 25 times slower as your performance, and do you want to take that hit? Understand what the costs are, kind of you. And again, this view is also taken out of context. It's blown up like mad. It's nearly 500,000 views so far at the moment, at the time of recording, and so it's clearly gone viral across the programming world. Unfortunately, because it went viral, a lot of the context got lost, and because the context got lost, people just were adding their own context into it without even bothering to learn it. So the context was, this comes from a series that Casey's been doing on computerhands.com, where it's a performance awareness course. So specifically, this is the programming course he's been doing performance awareness stuff. And this is a subscribed based thing on here, and it's been doing many different topics on here as those to learn how performance awareness. Specifically, this was the blog post, and he made completely public for everybody, showing all the code, showing all this stuff. So then you can see a whole video. It's all kind of transcribed down, and it's part of a series. It's not the beginning of the series. It's quite in the middle. So it's kind of like, oh, okay, we're not starting from a random place. So, and also when people say and talk about the context of this, Casey understands this like, look, reminder, I don't think clean code is bad just because of performance. My recent video is about poor performance because it's part of a course on performance. This is the context many people lost. And he's been doing this for decades, as saying, so I recommend reading these tweets. I will try and provide all of the links to everything I'm showing today in the description or the doobly-doo or whatever you want to do down below on YouTube. So it'll be here. So yeah, hello. Good. So to give a background, this perked up the attention of Mr. Robert C. Martin, which he colloquially calls himself Uncle Bob. For this talk, I'm just going to call him Mr. Martin, because I just prefer saying Mr. Martin. Insert your guesses as to why. But yeah, he is very well known for mainly three things, which is the Agile Manifesto. He helped develop that. The solid principles. So the Agile Manifesto and solid principles. Which again many people know from the OOP world, and especially that, and he wrote it in his book, which is first in design principles and design patterns, as it says on here. And he's also in this thing known for clean code. So clean with a capital C, code with a capital C, trademarked. This is his particular thing, the capital C clean code thing. Okay, and this is what he kind of tries to describe. So to get to show my biases and my background, I am the creator of the Odin programming language here. And the Odin programming language is the general purpose programming language with the distinct typing built for high performance modern systems and data order programming. So clearly I'm showing my biases, and I'm clearly on more like Casey Muratori's side when it comes to this discussion. And also I work at DjangoFX on Emogen and Liquidgen and GeoGen, which are all high performance real-time pieces of software like simulations. So again, Emogen's for fire, smoke and explosions in real time. So clearly I work in an industry where we really care about high performance real-time stuff. So clearly I'm showing my biases straight away so people understand what's going on. Okay, so now you know that's on the way. Can we explain what clean code is before we get into this? So sure. So there is this kind of little document I found the other day, and it's been actively updated by the looks of it only 8 hours ago at this time of recording. And today's date is the March the 30th, I believe. Yes, March the 30th. So it's very active already. Someone's updated. There's probably some typos and such. We can even see the revisions. And yeah, it's just just capitalizing some stuff. That was all it was. Now, many people have seemed to have liked this. Clearly, over 5,000 stars and over 1,000 forks of this gist as well, gist, or I don't know how we pronounce it on GitHub, and explained some of the general principles or points about clean code. Now, there's many of this. This is the thing about which is why clean code, capital C thing, trademarked by Mr. Martin, is very popular, because there's many of these rules which no one would disagree with. Like, follow standard conventions. Yeah, because conventions are a good thing because then you're working on the same song. Only break them when you need to. Keep it simple, stupid, yeah, fine, whatever. Boy Scout rule, leave the campground cleaner than you found it. Always find the root cause. Yeah, no problems like this, yada, yada. Now, some of these, some of these are not essential. These are accidental. Like, again, follow standard conventions. That's not unique to clean code, is it? You can do that in any philosophy out there. It's not a unique principle to clean code itself. But some things, like, for instance, I would say more essential to clean code are prefer polymorphism to if or else cases. And separate multi-threading code, I'm not even sure what that means. Use dependency injection. Follow the law of Demeter. Or many other things like here, like, use small functions. Functions, they only do one thing. Use descriptive names. Like, again, that's descriptive names. Everyone agrees to that to a certain extent. Prefer fewer arguments. Have no side effects. So be more functional, it means. More rather than be like, have side effects itself. Like, be more imperative, relying on, like, global state or modifying state or whatever. Don't use flag arguments, yada, yada. Like, okay. Some of these people will agree with, some people will disagree with them. But here's where the problem is with some of this. Is that, for the most part, some of these rules, people will agree with, some of them don't. One of them particularly is like small rules. For me, I actually disagree with this particular thing. There was a post here. This is on Jonathan Blow's blog, a very old blog actually. This is from 2016, but it's actually even older than that because it's an old email response between him and John Carmack. So this is John Carmack explaining effectively what he preferred for the thing. This is not the clean code up. This is what I wanted. It was the wrong one. Whoops. Let's go to the blog post again, and it's this one here. Sorry, I accidentally clicked the wrong button then. So this is John inline code, and John Carmack in the email is explaining that actually he doesn't like the separate single functions here. It's better just have one big function and then comment them. Now, some people might say, but it's easier to manage looking at read things. So, yeah, for code reviews in a big corporate setting, it might be easier looking at a single function. But there's a few things you have to understand. Functions have costs. If you split these things into multiple functions, this is it's an extra cost. Yes, there's a minor cost when calling a function, but like that, most people don't care about that cost unless you're doing particular things like you're worried about stacks or anything like that. Like, okay, most things don't care. One thing it does do is it doesn't mean it's very easy to optimize for the optimizer. And I know how compilers work because I work on them for kind of a living. And if you have things in line, one, it's not harder to read by just using comments everywhere or block codes or anything like that. I think that's just as easy. And if you've got text editors which use collapsible things, that's great. That's okay, no problems. Just deal with it that way. But then it's like, okay, but the optimizer is going to be better. It doesn't have to worry about trying to inline that function and then now optimize the new inline function that's been got inliners out of another function. So there's that. And also you can usually start to see easy patterns as well. Like if you were starting manually inlining things, it's not hard to read. Yes, okay, you've got 10,000 lines, but most people's IDEs and text editors are very easy for code folding, code searching, code organization. We're not living in the 80s anymore, or even the 70s, to be honest, because even Smalltalk had better options than this. I'm not saying I'm a big fan of Smalltalk, but like, again, the tooling is, the argument going small function is more of a, hey, it's our code review practices of big corporations, testing practices, and also maybe just tooling practices. So that's one thing. But again, I recommend highly reading this article. I really do, from 2014. Again, it's from 2007, as it says here. Highly recommend it. But what I'm trying to get at here about the word clean code, and I'm not even talking about the actual discussion that Case Muratori or them have been having yet, because I want to try to build up a picture here, as you can probably tell, trying to be a storyteller. I'm not very good at it, but let's carry on with it. Is that the concept of clean code is what I want to, the term it, capital C on both of them, trademarked for Mr. Martin, is what I'm going to dub a pork barrel name. So a pork barrel is a thing that, American English, but it's kind of a, you have this bill, and it has a particular thing like Citizens Against Government Waste, but it also has all of these things that are nothing even related to the actual name of the bill. And to keep it in American context, because I know most people watching are going to be Americans, so I'm not going to use an English example or another European example like German or something. I'm just going to use an American example. I've run a recent one as well, is the Inflation Reduction Act of 2022. The name of it, the Inflation Reduction Act. Okay, now I'm trying to be, again, I'm not an American, don't really care politics, but I think most people would agree This act did not reduce inflation. In fact, it printed more money and more excess money. That money was not being in high demand. So it increased inflation. And in fact, it had loads of other things in there not to do with inflation. But a really clever political rhetoric trick is to say, oh, you don't like this bill? Well, you must like inflation. You're bad. Everyone dislikes inflation. So you must be, oh, you can't be against this bill, can you? It's like, but this doesn't, no, it doesn't influence inflation. How dare you? You don't want to, you can do this trick. And again, it's not a political side either. Literally all political parties, all politicians, I do this trick. Some countries like to do, just get names from bills, but then they'll give them a name anyway, like a colloquial one to refer to it, rather than giving it like a letter or a number or some random numbers or something like that bill. And they'll just say, look, no, this is what we're going to call it. Because technically, internally, the American ones do, but they give them a proper name and also a very long title. Again, this is to provide for the reconciliation pursuant to Title 2 of the S. Con. Res. 14. I'm just reading it as it says on here. And it's like, okay. But that's a good example from a political standpoint. I'm just keeping it here, trying to keep it politically neutral. I don't really care about the politics, but it's just one of those funny things that show, hey, this is a trick. Because Mr. Martin will actually continually do this throughout, and he will do a lot of pivoting and a lot of these pork barrel names. Okay? So let's just say this is a good example of this. Bad code. Just say no. And it's like, okay, so what's good code then? Because then he phrases it in it's clean code, obviously. Now, there was another tweet I tried to find, but I couldn't find it. It's probably been lost to the Twitter search, or it's just been deleted, whatever. But he will commonly do this, Mr. Martin, go like, oh, the opposite of bad code is clean code with a capital C trademarked. Which is interesting, because that means anything that's not clean code is bad code? Yeah, let's not get there. But again, to be very careful on this, I'm not going to be criticizing him. I'm actually in admiration of his rhetoric. He's a politician level when it comes to rhetoric. I mean this. And it's like, this is really good. He's really good at it. But again, he's been doing it for nearly 50 years. He is, 70 years old. He's been doing this sort of job since, even the early 90s. So, at worst, it's 30 years he's been doing this. He's probably been doing it for 40. Okay, that's what he does for a living. He's very good at this rhetoric. So that's why I'm kind of admiring it to a certain extent, in a weird Machiavellian sense. But sure, let's carry on with this, shall we? I've got some more things. Another thing in here, he says, when this whole thing happened, when he was talking about it, oh no, people don't like this code. But then he says some people do this. And again, showing he's very good. He's very good at knowing memes. He's not an old man. He's an old man, but he's up to date with a lot of the stuff. And it sounds like silly, but it's not a book or the concept. It's a cartoon pandering immature behavior. The author bashes everyone. And then he just shows this clearly hey, I know how to play your joke. And he does. He's not that bad. But then there's other things. So here's case Muratori comes up with, and then he's talking about people criticizing it. And then he replies to this. This is where kind of the start of the conversation's happening. So Casey says in this, even if true, to what extent would you tolerate yes, clean code is much slower, but it's about programmer productivity for other products. Would you want a car that went only 5 miles per hour because the designers could do less work to make that car? Now, Mr. Martin replies, well, the automotive industry, notice he does a pivot. This is a pivot, and also it doesn't answer the question. It says, the automobile industry takes advantage of every productivity tool they can reduce their enormous manpower costs of designing and manufacturing cars. As a result, cars have gotten exponentially better over the decades because the extra productivity translates to better designs. Yes. But do you think for their programming, they're using clean code principles? In fact, we know they don't. Especially they have to use Mercer and stuff like that, but they have to adhere to certain other things. And they're probably not doing clean code stuff. Now, I know the most things have started to relax, especially when it comes to Android Auto and Apple CarPlay and stuff like that. Those stuff are buggy. But that's kind of oh, it's your phone. That's a different thing. It's just we're interfacing with it and whatever. And it's interesting he does this because he does it again when someone replies to it and everything here. But he's kind of he knows what he's doing when he says these arguments. That's not answering the question. All I'm going to say is that. Just watch that, okay? Another thing, it says, this is when it starts. This was the beginning of it. It's what's your thoughts? And it says, I've commented on this before. Clean code is made for programmer performance, not algorithmic performance. If you need the latter, then write in C or assemble and live with the high cost of development. So, few things there already. Programmer performance and algorithmic performance. Okay, so programmer performance, it's in the contrast. How do you measure that thing? How would you know if that your approach is better than another approach? And if you need the latter, write in C and assemble. Okay, it's assembly I would call this, but yeah. And then high cost of development. So he's already implying that writing in C is going to be a much higher cost of development than writing in another language. It might be, but you should only write it because you need the performance. And it's like, okay, what? Look at the framing. He knows what he's doing. I'm not saying he's an idiot. He's very smart. Okay? I'm sorry, I'm picturing it. You can already see which side I'm in, but I'm just trying to explain the rhetoric tricks. So this is another thing. It's like the clean code, reply to later with the automobility amount. I've got these flipped around, but it doesn't matter. People says, how do you measure readability of the code? By reading it. Oh, so obvious. But it's like, when people say measure, they usually mean a quantifiable thing rather than a qualifying thing. So this a quality and a quantity are two distinct ontological categories, okay? Or epistemological, there are many different things, but just not get into philosophy too much. But you cannot quantify a quality and never qualify a quantity in a sense. They're different things. Like, hey, I have a tape measure here. Yeah, I can say it's got I say it's quality of being, I don't know, round and green and stuff like that. I mean, these aren't even very good qualities, to be honest with you, but it has quantities. I know its mass. Just by dropping it, that's what you need to do. That's absolutely fine. And it masses. I was just trying to explain the gravity thing. So clearly it's got mass, and we can measure that relative to other things that weigh things. So we know how much this weighs. This is probably weighs about, I don't know, 8 ounces, so 225 grams-ish. That's quite heavy, actually, surprisingly. It's not even a good one. But there's kind of the thing. So you can actually think, you can sort of say, oh, how green it is. Well, we can measure the reflecting of it and then see how much it reflects back a certain light and certain wavelengths and such like this. You can say all these quantities, and these are quantities, okay? But I don't want to go into too much. Clearly, I used to be a quantum metrologist, so I know a lot about units, use measurements, and all this stuff. But this is a clever trick, by reading it. That is not a quantity. And people are wanting to question, how do you measure it? We want an objective measurement. What they mean is they want a quantity. But he goes out by doing this. So this was a big, long twist post I've been in here, where Loris Crow, again, SIG community anyway, says people on Handmade are hating on Casey's videos about performance, while their company is spending double digits of percentages of their revenue on Amazon Web Server bills to serve 3 forms in a database. View, and it's like, okay, this is great, night discussion, talking about this. And then Mr. Martin says here, his analysis was correct, his rhetoric is a bit disingenuous, and the overall point was extraordinarily narrow. Clean code is about increasing programmer performance. He keeps it straight with this, not computer performance. What are some real life non-trivial code bases that support the hypothesis that strict clean code increases program performance? Replies with a meme. Again, he knows what he's doing. And I'm not, like, this is really cool. Like, he knows what he's doing, but yeah. So you don't have any evidence at all. Like someone says it. So the Vittorio Monomir thing, for other people, I got into a discussion with him around about this time, and I kind of partially convinced him about, like, well, you've not got evidence for why one's better than the other. Like, show why. How do you know one's better than the other? It's kind of that question. Like, how do you know? What measurements are you using? What quantifiable or even qualifiable things are you showing? Like, can you just show me the evidence? And then he goes, like, he knows this for a fact. He says, the problem with scientific data is it's controlled in controlled experiments in realistic software environments that are economically infeasible. You're asking for something you'll never get. And yet you still decide. So look around and ask your associates, especially your seniors. So first, look, it's just the first part of this thing here is we have no evidence for our claims. But it's okay because your associate seniors may agree with me already. Nice little pairing here. It doesn't do the same thing, okay? That's the first thing. But then and someone said, like, they said they use over the 10 lines of code sometimes. Wrong seniors, I guess. And someone saying, like, well, my seniors don't agree with you. Says, oh, sometimes, of course, your seniors were correct. I presume they also told you that or else being or smaller, well-named functions are better than really badly named functions. It's like, okay, notice the bad pairing there already. A well-named function is better than a badly named function. Agreed. Smaller function may not be better than a long function. But notice is smaller, well-named functions are better than really badly named functions. Never talked about the length of it. I know it's like a minor word difference, but he knows what he's doing. And also, he just changed the topic again. It's a pivot. He's gone from being the scientific data to now to, well, trust the authorities of your seniors or elders or whatever. Like, that's going to authority rather than going to, like, empirical data. Nice little pivot. He knows exactly what he's doing. So another one here is, always remember that computers operate on one effing character at a time. He's trying not to swear here. no matter what lovely subroutines you might be using. Someone replies, what about Sunday? Well, the context of the problem was JavaScript in a browser. I'm like, what context? I even tried to search through the other tweets. There was no context. So, yeah. Okay, carry on. Another one. Someone has recently equated clean code to over-engineering. That is, of course, an oxymoron. An over-engineered code is by definition not clean, and makes me wonder if those who complain so loudly have actually studied the target of their complaints. It's like, see the problem? So if it's over-engineered, it can't be clean code. Even though I've seen many clean code which I'd class as over-engineered. In fact, I think clean code by default is kind of open-engineered. Like it's assuming this could be open to change, even though it's a closed set of problems, which I'll get onto a bit later. So then, talking about this Rhetoric Romeo chat we had earlier, I was discussing with him previously, and he was kind of like, oh, well, I can make it even faster if you just change the entire side of it and just have arrays of separate types. And I was just like, are you being honest? But this was the conversation I had with him and trying to confuse him. He was kind of being a bit confused, but also trying to be like explaining it. And we kind of got to a point where like, oh, okay, like, first off, you're being a bit disingenuous here, man, with the argument, but fine. This is not Mr. Martin anymore. This is just me explaining, like, there are people who are trying, not saying to defend him, but not understanding, like, Casey's point in this discussion. So again, before I'm going to read this article, I recommend reading this clean code, horrible performance YouTube video. Again, links are in the description for all of these links, so don't worry, they'll be there. So now I've done the 20-minute spiel at the beginning of this video, let's get to the meat and potatoes of this entire thing, which is the written down talk. Now, this is quite interesting. And this written down talk is effectively a written discussion between Casey Muratori and Mr. Martin. And they are both discussing with it. And it's been split into different things. And I'll explain some points as I come along. And so other little tricks. So first off, I'm just going to try and read it. I recommend reading this. Again, links in the description below for everything. So Casey starts off with, thank you for taking the time. And he's just kind of asking his questions like, so most explanations on clean code I've seen that you include all things I mentioned in the video, like preferring inheritance hierarchies to if state switch statements. Again, remember, if we look back to the where was the gist I found? I've completely lost it already now. It was here, right? Here it was, here. Yeah, here's the design rules. Like that, someone says that's not Mr. Martin's himself, but yeah. But it sounds like you were surprised to hear me say that, like all these different things he said. It's like, look, and Martin's going, the disconnect, I'm not sure there is one. And interesting, he just says there is no like disconnect, and Casey's just asking questions about this. So Casey's asking a basic question here, like, look, we're both familiar with Visual Studio and Clang, and would it be reasonable that you're calling the and he uses these every day? I use these every day. I use LLVM and Visual Studio every day. Are you calling these a vast majority of software that require less than one things? And then he would go like, oh, these are very specialized software. They're only a few in existence, and only a few that have actually become popular. And then talks about why this is the case, and like actually talks about all these different things here. Like, okay, speed is not necessarily an issue, but you can summarize. I'm trying to summarize it, but then the first trick he does, this is going to be consistent throughout here, is the nanoseconds, microseconds, and milliseconds framing. Brilliant framing, I will tell you this. So what it will do here is making sure that parsing code preserves in nanoseconds can have a big effect. Or it says, I assiduously counted microseconds when it mattered. Nanoseconds were way beyond anything I could imagine. And so then Casey kind of questions this. Okay, so like, it sounds like most software that Casey actually uses, and so would myself, would when nanoseconds actually matter. In other words, Visual Studio, LLVM, GCC, Microsoft Word, PowerPoint, Excel, Firefox, Chrome, FFmpeg, there's a typo there, but TensorFlow, Linux, Windows, Mac OS, all of these. And Martin goes again, Mr. Martin goes like, oh, not exactly, rather my experience abroad, and does all the stuff, and then talks about this other applications would have modules in the millisecond range, and he says sort of these time ranges. It's a very like, he's trying to get the reader, because he knows people reading this, to think about it, well, most problems are in the ranges of milliseconds, so we can worry about some not nanoseconds. Most people aren't have to worry about optimizing nanoseconds, but it's like, you can have death by 1,000 cuts, and 1,000 nanoseconds is a microsecond, and 1,000 microseconds is a millisecond. So if you do things 1,000 times badly, and you can, you've now got into the other domain, into the other module, as he was calling this, the time module. Okay, fine by me, not necessarily criticizing that way of thinking, but it's a very weird framing, which, like, even if I read here, so it says, for example, I'm currently working on an application in which the vast majority of modules work well at the millisecond level, but require a 20x better performance. My strategy has been to write the millisecond modules in Clojure, because while slowish, it's very convenient language. The microsecond modules I wrote in Java, which were much more faster and more far less convenient. So it's like, okay, so if I use them all like Java, it's easier, it's much, how to put it, less convenient, but I can write faster code compared to Clojure, which is, I write code quicker, but it's not going to be as performance. And those bits he's merging together because Clojure and Java both want the JVM, so they can interact with each other pretty easily-ish. But he's just talking about the other things here. Now, one thing I found interesting is this slash here. You'll see in a minute. Right, and he only wrote a book. And he's like, oh, I wrote a book on clean code, don't you know? And it focused on the millisecond side of the problem, not the nanosecond. It's like, well, I'm not walking about the performance of the code anymore. But like Casey just goes down on the question. So Bob answers a very short question, milliseconds, of course. And then he answers again. Now you might be asking, wait, why has he answered twice? Well, he went back in history and added some code, text. He rewrote history. Yeah. I'll say no more. But yeah, he keeps going on about this, and it's very interesting. So now here's another problem he kind of talks about. And he talks about the actual, he says he's now actually finished watching the video, because he didn't actually watch the video when he started discussing with it. He only watched the first bit of it and thought, I've got enough of this. It's like, you're not going to have a discussion with someone you've not even watched the entirety of, but you think you're confident, you know you can talk about it. I'm like, interesting. If you're that confident, it usually means you're not actually talking about the thing itself. Yeah? Yeah. But he says, you notice a nice little pattern. I love that beta formula of like some coefficient times the length times the width. And in those moments, it's like, I only think programmers and mathematicians can truly appreciate. It's like, oh, yeah, like, oh, it's fine. Isn't that lovely? And that's fine, whatever. But Casey comes up, okay, that sounds great. I think we've gotten to the same page because he was actually talking about this, not this. Because he says, oh, I've just finished watching it, so I'm going to add this bit back in to make it split it up. Again, take it as you wish. What I'm trying to say is above paragraphs, above the box, and that's just like, look, Casey has read and looked a lot of it. Like, what you're talking about, he seems like these nanoseconds seem to matter. Like, everything seems to be nanoseconds modules. Would you say, is like, all this makes no sense? And then he replies with, well, I'm one of the signatories of the Agile Manifesto who still believes to be a bit upfront of architecture design. Okay, but why bring that up? Sure, but fine. But this is the bottom line, of course, is that single factor analysis is always suboptimal. There's no one true way. A point I've always made several times in clean code. And it's like, but there may not be one true way, but you do kind of suggest there's a default you should go to. And there are arguments for that. Okay. So, look, Casey has a lot of questions he wants to ask already. All of this. Again, I recommend watching this. Now, Casey says here is like, I watched a multi-part series, a 6-part section, and it's like 9 hours he watched. Not once in that 1 second of it, of that 9 hours, was any dedicated towards performance. And again, Mr. Martin says it's fair criticism, absolutely fine, no problems. But again, I'm just going to show you here. It's like, yeah, so thank you for the nudge kind of thing. Like, oh, next time I'll put a nudge in towards performance. It's like, you've been doing this for decades. Okay, so clearly you don't see, like, but like, he's kind of buttering up, trying to be polite, like as you would, like you're trying to be conversational. I'd always be polite to someone as well. I'm trying to be nice and kind to a certain extent. Maybe not always nice, but kind, at least kind. But yeah, it's always kind of those kind of things. And I have some reflection, blah, blah, blah. So I'm just trying to go through over this again. It says that's fine. Knowledge is all accomplished. Again, that's a lovely conversation between two people they're just being honest between each other, not being horrible. Casey was also showing off this video, which, if I believe it's correct, they were just joking about how slow it is to write GitHub. Literally intent of just slowing down the longer the paragraph got. And they actually found after a while why this was the case. The thing they found out was that the code was looking back to the beginning of the paragraph, looking for a colon. And if it found a colon and it was near the beginning, it was going to then expand this to be a emoji. That was what the slowness was. So if you just, as Bob made here as a joke, like, oh, if I just replace everything with the spaces with the colons, it's instant. There's no slowdown because it's found the colon, found it's not an emoji, and doesn't do the search anymore. And that's how slow. Like, even though they were talking about the complaining like slow code, it's like, look how dumb this algorithm was in the web browser, and it's just trying to do this. Now, one little thing I found a bit weird. It says I created this using VI, and I use this like replacement thing because really I'm an old C hacker at heart. I'm like, what? What does that even mean? Like, this just seems like I'm an old C hacker at heart. I'm like, this is just you're in like VI or Vim or whatever you want stuff, and then you've just done a regex text replacement, and this has nothing to do with C. I know what he's trying to say. And that's, it's just really low level. I'm doing all this. I'm like, what? Sorry, it was just me, one of those things like the what? Right, kind of a bit interesting here. So then there's again, recommend if you're trying to read the links in the bottom for all this, so I'm not trying to read the actual descriptions here, I'm just trying to go over it. So now they've figured out the things, the slowness of GitHub, they've gone back, pivoting back to this, talking about the stuff about clean code again, capital C, trademarked, and explaining all that. And some of the weird things, like for instance, the descriptive names things. Like, I think everybody agrees with descriptive names. This is not clean code, exclusive to clean code. Tests. This is one where he's more of a test-driven development, while Case is more of a. They do frame it later on. In fact, I think Mr. Martin rephrases this quite well. That he prefers like, well, you should write a test if you don't see a reason not to, and Case is more in the camp, I write a test when I need a reason to, kind of thing. And they're not bad. One's more test-driven. One's more of a base of regression kind of thing, or like other testing in general. It's more of I'll write tests when I need to, because I do have tests in general. It's just not a like unit tests or general tests for everything, code coverage and all that lot. It's a different thing. I'm not going to criticize test-driven development because it's not necessarily bad in certain domains, but in certain other domains, it's kind of like not. It seems like you're writing more tests than the actual code, which is not necessarily productive, but whatever. Or useful. And there's many different things in here, yada, yada, yada. Yeah, so he says, like, look, cases, I do tests as well. But then again, here's the difference here, right? So Mr. Martin says, I write tests unless there's a good reason to. This is Mr. Martin. And Casey, write tests when there is no good reason to. When there's a good reason to. So it's kind of a different distinction here. Now, he actually starts quoting again from his book, talking about this. And he kind of distinguishes between the operand primal and operation primal, he's calling here. So it's kind of the difference between, I'm going to call operands variants in this case, because it's a variance and operation, so they're not using the same O. Gets a little confusing for me. So now they're kind of talking about the different benefits of using one of these two things, and great stuff here. But then there's one other term that he brings up in here, which is dependencies. And he's using this in a very, not the way that most people would use the term dependencies. So a good example of this would be, he's calling it dependency inversion. So I'm just going to I'm going to say what he's written, because I'm not going to paraphrase it very well if I don't. It says here, that would be the bottom line if there was one other thing, okay, about dependencies. The cases of switch statements create an outbound network of dependencies towards lower level modules. And modules in this case, he's talking about like the timing and such like that kind of module in this context, yeah? Each case may call out to these other modules, making the fan out of the switch statement very high. So he's trying to argue against switch statements and trying to say, look, if you go for the more polymorphic approach, like the inheritance-based approach, where you have like a V-table with subtyping, which is what I would class as inheritance to begin with, anyway, it's the emergent construct of those two things joined together. He's saying that this is going to be making the fan out of the switch statement very high. Like, this is going to be much bigger. Because, okay, let's carry on. What it says, any change to one of these lower level modules can force the switch statement. And Casey uses switch statement in the video. He usually prefers the inheritance style, not always. You'll get into that. Can force the switch statement and all higher level modules to depend upon that switch statement to be recompiled and deployed. That can be a very large cost. On the other hand, if one uses dynamic polymorphism, object-oriented, instead of a switch statement, then those compile time dependencies are inverted. The lower level modules become subtypes that depends on the higher level base type. And the source code dependencies then point in the opposite direction of the control flow. This is dependency inversion. It prevents changes at the low-level modules from forcing a wave of recompilation redeployment from sweeping through the system towards higher-level modules. So this is actually just a really weird, confusing terminology he's just made up. In a weird way. I'm saying, who else made it up? I'm like, no, he kind of actually has. I tried searching for this, and it's like, it's not consistent what people mean by that term. And also, when people talk about dependencies, they usually mean like third-party code, usually. Or sometimes they talk about dependencies like, hey, what does this variable depend on other things, like all the bits in the thing. Like he's talking about modules, but his concept of a module is much more like a class than a library. So it's kind of a very more old-fashioned approach. Before, like libraries and packages and modules were more like standardized in other languages, obviously. But whatever. This is why I'm getting confused, because the argument he's trying to make, and this is the thing I would personally try to understand as well, is that between the variants and the operations, the switch statement is closed to the number of variants, but it's open to the number of operations. Like, for instance, you can always add more operations really easily. You just add a new function with another switch statement inside of it, and you've now added a new operation to all of these different variants. Yeah. Whilst the inheritance style is much more open to variants, not operations this time. So it's a closed set of operations, but open to numerous amounts of different variants. This is the whole point. You have a base class and variants, like subtyping from it. The whole point, you have subtypes or whatever, and it's more open that way. So it's a lot more useful to be doing, if that makes any sense. Yeah, hopefully that's clear. So that's kind of the argument. Now, my personal view is that, which is again talking in the thing here with the commentary such, is that most of the time you actually have a closed set of variants, and usually you want to add more operations in practice. So because if you've got a closed set of variants, why are you pretending as if it's completely open? Which is what inheritance is for. It allows everybody to add more variants, even if you don't have control of that code base. You just extend to it and it's abstracted away. But most people within their own code base, like, it's not going to be used by third-party people ever, usually. Pretty much isn't. So in that case, it's a very closed set of variants you have. And usually when you're modifying code, you actually want to add more operations. It's kind of like a different thing. And they're solving different problems. You have to understand this. It's just that the weird oddity here is their argument is actually, the inheritance style approach, which has all of the operations for each variant bundled with that variant, is easier to manage. And they're going on about like managing all these different dependencies and talking about how many different places you have to deal with. And Casey does correctly point out, like, hey, it's just a different win in different ways. Like, this dependency inversion thing is you're just trying to complexity. And then again, Mr. Martin says, yeah, like, for every program composed of O operations and T types has a complexity of O times T. If we use O, we can increase T with minimal disruption to O, increasing O, and vice versa. Well, it's like with switch statements, you have increased operations with minimal disruption, but disrupt source code. Now, I don't think this is true. I don't think the disruption is actually even equivalent, because it's weird. I know I shouldn't be talking about much more. This is not really clean code anymore, but it kind of is related to it. It's just but practically, how would you know which one is more true the case? Like, in my opinion, personal experience, we've always had a closed set of variants. Like, if you want to have a new one, fine, but that variant doesn't really, like, okay, we've got to update it in every single place. Now, I use Odin, so my switch statements will yell at me if I'm missing a case by default. It says, oh, you've not handled this particular operation for this particular variant, like in this particular case, and I just need to handle it. Okay, great, that's just better. I know C and C++ and some languages don't do this by default, but Odin does. So clearly that's just a better language can solve those problems. It's not really or better tooling in general. It's not really a inherent thing. It's just a tooling problem then. But then this is where it gets a bit weird. He starts breaking things down to source code management about runtime, source code, dependency inversion, and just makes some terms up which are not colloquially understood to be meant in that context. But again, it's the write a lot of text, try and make people understand how he thinks, and then Casey just writes small amounts. It is a very big politician thing. Pad it out. Very good rhetoric. I mean, he's great at this. This is where I'm praising him, by the way. So again, read it for yourself, make your own opinion. If you disagree with me, Ken, tell me in the comments below. Tell me where I'm wrong. Please tell me where I'm mischaracterizing me. If I'm being too harsh, if I'm not being harsh enough, if I'm like, look, I'm not even, it's fine. But it's fine. Like, just read it. He's talking about these different things here. Like, he's procedural stuff, which is if-else statements, switch statements, whatever. And he's calling this a high runtime dependency, when actually no, we're going to make this compile time dependency when it's on the type. It's like, no, you've just switched them around. They are both the same. So yeah. So one thing he brings up here, which I thought was interesting, and through this bit, as well as the second part that he starts up, I'll explain why he does that in a minute, he brings up what I would call the canonical case for inheritance. So the canonical case of inheritance is the data stream. So sorry if I've been a bit rambly all today. I'm just trying to understand it, because it is weirdly flowing as well. Like, the actual thing isn't like, it's a weird discussion. But so I apologize for that, and also apologize for my rambling as well. So hopefully that's okay. But again, should be all clarified here. Here he does the canonical case for inheritance, which is literally a stream, a data stream, a file, or something like that. And explains that, oh, these have standard operations, a closed set of operations like open, close, read, write, and seek. Again, these are the 5 standard functions of the Unix I/O driver. And again, these are very standard functions on all operating systems. So they actually map really well to the inheritance style of doing things, the very dynamic polymorphism, as he's referring it to here, which is, yeah, it's dynamic dispatch, it's subtype polymorphism with vtables, yeah, that's what it is. But he's calling it dynamic polymorphism, which is not a common term, but he's whatever. He's using his own terminology as he needs. But it's saying like, okay, we've got a closed set of operations, but we have so many different things. Like files could be anything. They could be a file, it could be a directory, they could be a piece of hardware on your device, they could be just a general socket, they could be anything. It's like, it's open to be whatever it could be. This is literally the canonical case. Why is it the canonical case? Because operating systems make these files an object. They are an object. That's what they have. Like, they're an abstracted away, opaque thing with an open, like closed interface as to what they are. So he's trying to argue, like, this is what you meant to do. Now, there's a lovely thing here. Is he's saying, like, well, this clearly has to be a thing. And that's what he's trying to get down this route. He's trying to take the canonical case to show to Casey that, hey, you need inheritance sometimes, and this is the great way. He's completely forgot the conversation he's talking about clean code, which will bite him in the butt later, to use an American phrase. Later. But then there's this weird thing he does here, where all of a sudden he talks about this hypothetical compiler, which would be able to, you could write in the OOPI stage, like inheritance style, and then completely the compiler would magically make this be a switch statement if necessary, which is kind of interesting, because it's like, what benefits would you get from that? Because it seems to be now textual benefits. Like, you're talking about, oh, it's all clumped together, a new variant, or you know the variant. It's like, but there's some weird things he just says. It's just a really weird hypothetical scenario he just kind of goes into. And they go on for this for a little while, and Casey's like, I don't understand what you're talking about. Like, this doesn't make no difference, even with this hypothetical case. So Casey goes on a bit more further here, just mentioning different things, and trying to get what the benefit of dependency inversion is anyway, and to begin with. And they go on about this, like, look, you've got a closed interface with opaque stuff and different ways of dealing with it. And then we talk about this payroll thing. They do all these different things. I recommend reading it, but it is going to be this, like, this is an OOPI thing, obviously. You've just defined it to be OOPI, because it is OOPI. It's defined to be OOPI, sorry. Yeah, okay. Yada, 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 yada. But again, Casey also kind of says it could just be standalone functions. There's no reason, whatever. That's not a problem. Where am I looking for now? I'm sorry, I'm just trying to skip through this because it just goes on for quite a while. Okay. So Casey says that, well, hypothetically, you could just not do this and have it just a union. Because in the example that Casey does when he does the union, the shapes example in the video, is actually a union. It's what I would call a fat struct union, or an open union where it has a variant and then just open fields. So it's kind of like a table-like thing. A fat struct is a term that Ryan Flurry kind of popularized. And it's kind of just like, here's a table of data, all the fields available, but hey-ho, you can just switch on it like all this and just do whatever you need to do and just access the data when necessary. And Casey's saying, look, hypothetically you could do this. You could just have a file type with all the data that responds to this in this union and deal with it. Because in practice, there's actually only a certain set of files you could have. You could even have the general case where it will be like a vtable. Sometimes it won't use a vtable, but you can always optimize off that. And there's many different things he's discussing here and such. And he's talking about the union case. Now, Mr. Martin goes here and says, look, it seems like I've come wound up at the agreement on just about everything other than individual preference. And it's like, no. He's trying to say, look, but we don't disagree. It's like, actually, why are you having this conversation if you don't disagree? You clearly do, actually. And you'll show this later on in part 2 of this written document. And he says, thank you for the union clarification. Now I understand what you're talking about unions, which is like, okay. And he says, I'll quibble with you a bit on the distinction between operand and operation, but I don't think the quibble is particularly important. In the end, it's just all functions regardless of how you spell it. As for human issue, performance is a human issue. The computer doesn't know how fast or slow an algorithm runs, but I think that horse is dead now. And it's like, no, it isn't. This is kind of the point. And he goes back to his microseconds, different module things again. And then he then goes, look, we puts a break in here to write extra bit more. To go rewrite history and says, look, I'm going to continue this now in the second document, which is the number 2. Because he's trying to like make a break here and then reframe the entire question in a second document. It's a pivot and a reframe at the same time. Clever rhetoric trick. If you want to do that in an argument, you do that all the time. You reframe the question, so it's now they're not even talking about the original thing again. And he's tried to do this. So that's what he's done here, right? So right at the beginning. And then Casey's reframed it and put it into the beginning, so he's first. So Casey knew what he was doing, so let's not do that, shall we? Yeah, so Casey wasn't stupid, was what I'm just putting here. He's talking about all this, goes back to the payroll example with all this kind of thing. And Casey's trying to say is like, look, this is not an open problem. You haven't got an open set of variants. It seems like it's an extremely well-defined problem. So why does this need to be like operand primal design, or in like variant open, rather than variant closed and then operation open? It's like, this seems to be both closed. Like, it's very weird. Like, what are you trying to have in like say developer cycles with? Like, where's this kind of thing coming from? And then have to find it's been moved to R2. Yep, because he reframed it. It's fine, no problems. He's talking about the programmer cycles thing. This is the thing. He gave this random file he added in here, which is the, oh great, let's do a code golf example, shall we? Cute surprise. It's like, the point is that program cycles waste management time and program cycles, blah, blah, blah. It's like, yeah, you just gave me a code golf example. The worst case of readability possible. Like, but it's a code golf. That's the whole point. People write those things to be compact and human. Like, that's what you're trying to say. Like, we're trying to make it easier on, like, can you prove my belief? Not mathematically. Just as I'm sure that you cannot mathematically prove that your favorite style saves more or less programmer cycles than mine. It's like, so he's already admitting that actually you can't prove my style is worse than your style. And it's like, because programmer cycles, like, this is a qualitative thing. He knows he can't measure it, which is actually, I don't think that's true, to be honest with you. It's just that no one's really bothered to do the science, because programming is a really young discipline. What, it's 70 years at best, really, as a discipline. So it has no evolutionary pressure on there yet to say which things are good or bad. So people just say random things. So it is literally just like, great. There's not really much science in computer science. It's rather, again, I'm glad the rest of the world calls it informatics for a reason. I don't know why we don't. We call it computer science, even though it's not an empirical science and it's close to mathematics. But even then, it's not really, in practice, it's close to engineering. It's, oh God, it's just a confusing term, okay? Confusing term. The dynamic was a dynamic binding, another type. It's just typos, whatever. I make more than this in my blooming day-to-day life. And he's talking about this. So it says, do we agree so far about all this? And it's like, Casey's kind of like, well, we don't disagree about certain things in the general, but like in the specific, I'm still asking the same question about this data stream thing you're talking about. Then Mr. Martin brings up again the, like, hey, here's something like the read-write thing for a C. These are helper functions, don't you know, to do all the stuff. And it's like, but if you had to do it in your case, we'd have to do a switch statement like this, wouldn't we, don't you know? Oh, it's like, look at all the different variations you could hypothetically do. This is just ugly. Don't you know it's ugly? It's like, actually, by the way, if you, this is going to tangent anyway. I've been writing the Odin core library, and you actually have to do this anyway. Like, if you actually have to do, like, you do the OS read functions, because the console on Windows at least does not act like a normal file. In fact, the console on Windows is a UTF-16 document, so that means you have to write UTF-16 files. So if you actually write a UTF-8 thing to it, you're then going to have to do a conversion to do it onto there. So it's actually like already you have to do this edge case. And not just that, the console has other things in it which are not handled the same as a normal file again. So it's a very... you kind of have to do this. This is how real world code. It's not even purely like, oh, the operating system has dealt this properly. It's like, no, I still have to check if it's a console specifically and then deal with it. So it's like, I know, like, this is not working. Like, yeah, it actually looks closer to this in real life, even with the abstraction on top of what a file is. But I digress. Yeah. But yeah, it's just interesting. And then he goes many different breaks, again, different edits here, different sections. He's breaking it up. The vtable used by Unix. Again, most operating systems do this as well. Things change around significantly. The IO device can be loaded at any time. The IO device, yeah, that's true. Again, it's the details we're talking about. He's talking about code reuse. It's a great example. It says the cases, look, I apologize, I'm trying to be very specific here, but I really want to actually get to the exact proposal. And it wasn't clear from what, could you actually tell me what the OS interface looks like and how it's implemented? You said, I guess that depends on a lot on the language and the application, but my understanding is that we're talking about the OS side. So, and again, it's how does the OS implement this? Like the stream, the file, compared to how we're doing it in a language is very different. And not just that, again, I thought we were talking about clean code. But why has it gone down this digression? Just you wait. We'll get there. Don't worry. Oh god. Okay, we're talking about GitHub crap. Okay, because it just changed. I can probably guess which day this was written on as well. Like you're saying, it seems like it looks like this somewhere. Is it actually a base class? Is it whatever? Now, Mr. Martin says, okay, here's kind of the general interface that you'd write in C++. Again, he's not actually answered the question he's asked. He's done another thing. Whatever. Kind of missed the point again. And then he's saying, look, if we look at he's trying to say this is less likely the code, it's easy to manage, whatever. Like, yeah, but you've just chosen the canonical example. And he says, look, if I do the dynamic polymorphism case, so inheritance, I create this. I have 3 files, and I have to lead them. But with a switch case, I've now got all of this, and look at all these different things I have to define. I'm like, and the case says, well, hold on. Since I'm the switch proponent, at least I get to write it, please. Look what he's just done. He says, well, I've just shown you how to do it, and look, it's just more complicated. I've had to write 5. Oh no. I'm like, case is like, hold on. Yeah, and it's kind of doing like this. So it goes on and on. They just discuss things, but it's like cases like, I want to know about the operating system again. And it's different. And I'm like, okay. And then cases like, we're not even talking about machine cycles again. I'm just focusing on the program cycles again, what like he's doing again. Sorry, I'm like paraphrasing this poorly-ish, but it's kind of just like, I'm trying to show the techniques that he's doing here, that he knows he's doing it. He isn't an idiot. I'm trying to be very careful like this. Mr. Martin knows exactly what he's doing. Like, he's now just made another document on here, which only he talks about. And it's just, he's trying to suggest, like, oh, this is the clean code stuff. And then he's saying this is what clean code is. And I've just got the summation. It seems to correlate with what most people think it is. But he says, oh, people keep misunderstanding me kind of view. And it's like, wait a minute. So choose carefully names, not unique. Keep your function small. Why? Keep classes small. Why? Manage your dependencies. Vague as anything. Literally, be careful with side effects. Okay. But, yeah, express yourself in code where possible. How else are you meant to express yourself in code? Oh, wait, it's your programming. Use polymorphism when the type changes faster than the operations. This is new stuff he's added now. Use switched when operating change faster than the types. Why? Why? And at what cost? And what Harvard evidence have you got this is better? And, like, you're comparing it to this. And, like, you sure? Okay. When possible, create designs where things that can change fast are types. Why? Keep asking this question. Here's in his summarizations of here, he's actually saying, well, prefer polymorphism. So now he's saying, like, well, I don't see how you got to that conclusion where, like, I'm against switch statements or something. I clear and prefer, like, default to like all this. I'm like, you're literally saying it in here in this summarized document. If I'm misinterpreting it, please tell me, again, in the comments or something. I'm just really confused. Like, what? And then he's got, right. So Casey comes back again, and he's talking about the internals of this. It's like, okay, find the device, then you read it, and you do this. This is how Ring versions, if you understand how they work internally. Okay, great. there's a class, here's the operations, and it's like, look, you could always do it this way around. And look, I've got a different way of doing it. It's just a union-based approach now, with all the data inside of it, doing all whatever you need, whatever. And that, I think that's just is actually trying to show the actual things internally, isn't he? But yeah, it's kind of like, look, now I don't like vtables as blank specific objects pretty much everywhere because I find them harder to control. So I prefer this. So he says, look, I have not a vtable, but just inline things itself. It's not a table, it's just inline functions. So instead of a class, you've now just got inline methods. And this is just general handling of a function thing, which is interesting. By the way, that will actually be better for performance in general because a vtable is usually a pointer to a structure of a function like function pointers. Whilst if you're embedding the function pointers, you've got rid of that indirection. So you've actually got, it will be faster in general as well because you've got rid of the indirection. It also has a better chance to optimize, and even it has slightly better chance of inlining, only slightly. But yeah, just that's how compilers work. Sorry, rambling again. But I'm getting off the digression. But Casey's kind of saying like, look, we could just handle it for each of them. We could actually have one callback, just one, and we could directly embed it in the structure, so it's not even indirected anymore, and then we switch on this. Now, this is interesting. You could do it for every single operation. And then look, the code's in one place for this thing. We've now got the best of both worlds in many ways. And why wouldn't you prefer this way, I think? Now, interestingly, I'm just going to slightly digression here, going into Odin. And this is what we actually do for the allocator. And I've been doing this for like, oh God, a decade maybe. Even before Odin. There is the thing. Sorry, apologize for the digression. This is clearly unscripted if you didn't guess. Here's the allocator. So in Odin, we have a built-in concept of an allocator. And an allocator is just a little data structure with a pointer to a procedure and a pointer to the data. So 16 bytes, you can easily copy this around. So it's usually not even a pointer to the allocator. It's just the allocator itself in memory, and you just get the values. So that's what you're doing. So there's not an indirection again because it has to be a pointer. And notice it's just in line with the function. And not just, there's only one function. You think, but there's loads of different allocation operations. Like, yes, it's one function. You take all the arguments in and you change the allocation mode. It's an allocation, alloc, free all, resize, query features, query info, and alloc non-zeroed. Because sometimes you want to be allocated without any zeroing. But by default, you want zeroed because it's quite useful. And also it's pretty much free if you're using like virtual memory. Like allocating zeroed memory is pretty much free. Because it has to be for security benefits. Like there's no option to not get it if you ask for virtual memory. So I'm just trying to show here that I already take advantage of this kind of approach. And then within every single allocator, I have a switch statement, which then pairs each operation together. So I'm just trying to get off my digression a bit here. So this is what Casey's kind of trying to say. You could do this. So you're not having the full-on inheritance style. You could just have a switch. You could do the blend of the two. And there are benefits to this, obviously. And you could have all of this. Lovely. So because in either case, but this is largely relevant because it's solely map lookup now and to a specific device, and it can be used in either design. Anyway, over the course of the development of the OS, I think the implementation saves programmers in cycles, potentially a lot of them, compared to the one I understand believed you favored by the clean code method. Again, which is interesting because the Casey one is closer to being like subtyping to a certain extent, but there isn't subtyping. It's just like, here's the abstract thing with a function pointer, deal with it. Which is kind of close to inheritance, but it's not. Just one. And it sounds like a minor difference. People say, oh, it's equivalent. It's like, but it isn't equivalent. And in fact, it will be faster. You can easily measure it. It'll be easier to maintain because everything's in there. And not just that, if you add a new operation into there, every single one will just yell at you anyway because you've not implemented it. So if you've got a language that tells you that on switch statements, obviously. Not necessarily C or C++. Maybe modern C++, I think. And sometimes C with the... when you have warnings all and everything, it'll tell you a switch statement is missing in certain cases. But yeah. And cases, look, I don't know if it's extracting file code is a big example, but it was the first one you brought up. And it happened to be the contrast of the two designs, in my opinion. So it works for me, as Casey is saying here. Here's why I think an enum-based design serves the programmer cycles. In most systems, you don't know all the functions that are going to be used ahead of time. When operating costs are hard boundary, like a driver, using operation codes instead of virtual function calls allows you to add more functions dynamically without recompiling all our drivers. Yada yada. In any modern operating system, multi-threading is a concern, but this is especially true for an operating system. Having the protocol be structured based with an operation code allows us to trivially buffer operations in things like I/O rings and other intermediaries, without writing any new code. The entire system remains identical. Yeah, I'm just trying to do this. And he just said, this is, by the way, it seems like almost happens in almost all systems. I see, I'm trying to get around pronunciations here, because eventually they need to serialize or something similar. And so they have to write my version as well as their version, but they don't seem to realize how much time they're wasting. Like, yeah, this is, to clarify on this point, people think this seems like the clean code will actually save time, but it's actually no, you're now forcing another person to write the same thing again. And you are actually wasting time. You think you're saving things, but like, again, if you want to know if you're saving time, you're making a statement like, this will save programmer cycles, like a claim, show the evidence. And don't just say, well, your seniors may agree with me because they were convinced by my argument. It's like, yeah, but where's the evidence, regardless of this argument by authority? It is the... After a while, many people will come out the oop phase and like, oh, I don't do this anyway. But some people don't. And it's like, okay, I never really went through the oopy phase myself. Going a bit of a digression here. Sorry, this is completely random today, I know. Very, very unstructured. But I went through the modern C++ like 11 phase. So that's what, 12 years ago now? Probably a bit before, actually, because it was C++ 0x for a long time. And I remember learning all that stuff, and that was the thing I got caught. It wasn't really necessarily the oop phase, it was that phase, so I was learning all that stuff, and it was a while, it took me a few years, and after I was like, I'm doing all this extra code, writing loads, and I'm not getting any more productive. In fact, it's how harder to maintain. I'm writing literally 10 times more code than I needed. And they kept telling people kept telling me, because I was kind of trusting these people who were I thought they were more experienced than me, or they thought they knew more because they've been doing it for longer, and they were talking from positions of authority to a certain extent, that they were going, oh, of course. Like, of course this is going to be better, because I'm telling you it's going to be better. I'm like, and then I was kind of believing them, even though I was like, this doesn't seem like, I'm trusting them. But it didn't seem to be the case. When I just started programming back to like a normal basic C style, with switch statements in many cases, and just like normal standalone functions, not even using methods, I got more productive, my code got smaller, got easier to read, just by not doing any of that. And it was kind of like not doing any of the stupid templates, not doing any of the ownership semantics. I'm not saying ownership semantics is stupid per se, I'm just saying being everywhere. It was like, look, I just kind of went to more POD data. It was a plain old data kind of style, old-fashioned C style. My code just got easier to read, more maintainable, and just everything. Like, from a personal perspective. Again, I cannot measure this. And the only way I can convince people is say, here's my code, here's this normal other code, which one do you find easier to read? And that's the only way. That's not a measuring. That's just still like a personal preference thing in the day. This is the problem in these discussions. And it is just getting down to that. It's like one side is... there is an empirical thing to a certain extent, which I'm going to comment right at the end. I will get to this, don't worry. But yeah, he talks about this, saying here, at any point, if we would like to have third parties to allow to communication with channels on the devices, blah, blah, blah. Okay, we're talking about the I/O stuff, fine. We're nearly getting the end. So Mr. Martin says, okay, I think I see where we're going. So let me say, sure, looks good to me. The bullet points you added are after the fact are all quite valid. And the design you picked works well in this case. In the first point, you assume that operations will increase beyond the two original proposed. As we both agreed, as I wrote in the clean code, which, by the way, is not the same as your clean code. Right. When operations proliferate more rapidly, typed switch statements are better. So there's that line alone is, another rhetoric trick. Lovely one, in fact, in my opinion. In the first point, you assume that operations will increase beyond the two originally proposed. Okay. As we both agreed, I don't think Casey agreed to anything. And secondly, Casey's not calling what he calls clean code. He's trying to understand what your clean code is. Casey never says his code is clean code, because yours, Mr. Martin's, is clean code with a capital C trademarked kind of thing. Yeah. So another little kind of trick he does already, and he can't help himself really. So when operations proliferate more rapidly typed, switch statements are better. In point 2 and 3, you raise the specter of multithreading. You are, of course, correct that queuing operations is a lot easier if you request packets of the same type you design. No argument there. And the last point proposed a kind of hook for unknown and unspecified possibilities in the future. Yeah, so what he says is like, okay, you have the general cases and then have a hook for the unknown cases, like the open cases. Okay, if you think those unknown cases and specified are likely, then you should have considered them earlier. But then that raises a number of other concerns that we should not likely address in this document. It's like, no. So I think I'll let that pass. No, why? Because if you didn't, it has to let that pass, because it then kind of defeats his point. Because the inheritance approach, which is preferred by clean code, is saying that the open case is the open set of variants, the open set of operands, is the general case. It isn't. Because if you've got a closed set, which you know, like pretty much always know, that 99% of the time, 99.999% of the time, is going to be closed, like pretty much it's going to be that small set. So you're optimizing for them. And then you've got this the unknown hook cases. You allow the user to add their own callbacks in there, fine. That's fine. But it says unlikely to be considered ahead of time. It's like, yeah, but you're assuming that those unknown cases are just as common as the known cases. And that is actually a design in the API. Now, the thing is, if you're optimizing for the general case and then you allow a hook in, that hook is not going to be any slower than if you design it to be always a general case than the specific cases. That's the point he's trying to say here. Like, that's why he's letting it pass, because it is literally just as fast to do it that way than to design it all the way around as if it was always unknown, as if it was always dynamic polymorphism. Sorry, just say inheritance. Be easier, because it's technically what it is in this case. So now, where are we? You propose a solution that uses dynamic polymorphism to select different types, and then a switch statement to select operations. I have no problem with this. It works well and satisfies my concerns about dependency inversion. I'm like, but it isn't the same kind of dynamic polymorphism that you've ever recommended to anybody. So this isn't technically clean code. In fact, anybody who, a clean code advocate, would read Casey's code of, let me go back to it, this, and go, that's not clean. So this leads to the problem of clean code is whatever Mr. Martin says it is at that moment. It's not like anyone can actually agree on what clean code is, because it changes from time to time. It's not a well-structured thing. And he's like, okay, that's fine. It's like, then why don't you just call it Mr. Martin style? Because it clearly doesn't work. It's not clean, and it clearly doesn't work the way he wants it to in every single case. But then it's, you shouldn't do it like a dogmatic. And it's like, it's a weird trick. He says, look, don't be dogmatic. Don't follow the rules. But then it's like, well, I don't agree with it anyway. Well, you agree with some of these rules, don't you? It's like, it's that clever trick again. It's the pork barrel naming again. It's the rhetoric over again. I'm like, look, even if Mr. Martin's style increased programmer cycles, decreased or wasted programmer cycles, like, or whatever, great. But how do you prove this is the case? And we're getting to the end now. I'm just going to do here. So I'm just going to read the best of it. So Ms. Martins, your proposed solution, dynamic thing, blah, 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 blah. What do you got to this? I will say, however, that it is ironic that after your video and after all the stress that you have been put on saving machine cycles, you eventually chose a design that sacrifices machine cycles to save programmer cycles. After all, on the OS side, this is where he thinks he has won the argument. Ready? This is what he's tried to trick. He's tried to do it because he took the canonical case of a stream. After all, on the OS side, you've got to package up all the request packets, hand it to the dynamically dispatched handler, and then run the operation ID through a switch. And I think we wind up in the same place. When operations proliferate more rapidly than types, we both use switches. You don't. You do not do this. I've read your code, your public code. You don't do this. But he's saying he does. Okay, let's just pretend he believed it, okay? When types proliferate more rapidly than operations, we both use dynamic dispatch. We are both willing to sacrifice machine cycles to save programmer cycles. No. Also, the way, again, how Casey structured it will be better because it's not technically, how many levels of indirection do you have before? Like, technically here has one level of indirection, which is a function pointer, compared to normal inheritance, which is 3 levels of indirection. Why? You've got a pointer to the object, pointer to the vtable, then a pointer to the function. Guess which one's going to be faster? Just have a hesitant guess. Okay? And not just that, you've then had to go all through these indirections compared to having one, which is probably going to be in the literally cached already, in the cache, ready to be called, no problem. It's going to be easily predictable as well for the CPU. It's a very different thing. Very different operation, that is, to a generalized vtable. So no, they are not equivalent even in performance. One will be quicker than the other. I'm not doing it in this video. I could do it in another video if you'd like, but like we could prove it. One's going to be quicker. Single indirection compared to triple indirection. Okay, so when we are two individuals on the same eye, and the only difference being that I wear this shirt emblazoned? I don't know how to pronounce that word, whatever. With clean code, and you wear one with clean code. I'm like, thank you for simulating the debate. I appreciate your candor and the civility that you've exercised here, and if not everywhere. I've come to experience your respect, your knowledge, and blah, 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 whatever. So the first thing is, this is a really dodgy thing. Casey, and even Casey's, well, I disagree with most of that, but if we're ending it here, I'll just finish my final responses for Gale posterity. And that is the thing. See how he tried to end it? And I'm going to read through Casey. I'm not going to comment on it now. I'm just going to read it for the end of this video because we've already been going on too long, sorry. So I apologize for my rambling in between. I hope it's kind of enjoyable. If not, I apologize again. So I'm just going to read through this. I'm just going to read Casey's stuff. This is all Casey, not me. So regarding, as I wrote in clean code, which by the way is not the same as your clean code. Well, the point of discussion was you to elaborate on what is not the same. But your design for the I/O system looks exactly like my clean code example, a virtual function for every operation, one class per element in the system with no predication. So what are these differences that you're referring to? Now would be the time to explain what they are, since that was the point of the concrete example. If these are a bad example for illustrating the differences, that's fine. But it was the first one you gave to assumed that it would be the one you want to use. Regarding when operations proliferate more rapidly than types, switch statements are better. That was not the case here. In no way are operations proliferating more rapidly than types in this system. Vendors will add drivers to the OS constantly, perhaps monthly or even weekly, whereas the number of operations in a particular system tends to go up much more slowly. Once every few months at a maximum, but more likely once a year for something like an I/O subsystem. It isn't the opposite of what you said. This is an important distinction because what I'm demonstrating here is the opposite of your rule. This is showing that even in the case where types proliferate far more rapidly than operations, as in the case of drivers in an OS, the principle doesn't work. Enums are better in both cases, or unions in this case, specifically because you have potentially thousands of types in the system. All different drivers, all the vendors have ever shipped. Adding a single operation, however rarely, can cost massive programmer cycles to the unnecessarily work multiplication across types that vtables cause. Another way to say this would be enums are more important in a system where types proliferate rapidly, not less. Regarding, you eventually chose a design that sacrificed machine cycles to save program cycles. I did no such thing. The design achieves both. That's why I like it. It's dramatically faster to use something like a packet-based system than something that is originally proposed design, because you do not take a ring transition on every operation. New OS I/O APIs are not all designed this way. This user writes data without talking to the OS, and a kernel thread picks up those data writes. Nobody ever makes a function call, except occasionally to ensure the kernel thread hasn't gone to sleep. This is what I mean by the bullet point. If at some point we decide that users should be able to do multi-threading bulk I/O ops, I am talking about the necessity that actually occurred in both Linux and Windows of removing their frequency of ring transitions for saving CPU cycles. None of this is trading CPU cycles for programmer cycles. It's achieving both. The Linux kernel design of the IOU ring looks like my design. That did not add to save programmer cycles. They added it because they wanted the highest possible I/O throughput. This is an almost universal principle of modern OS design. Anything that can be turned into data writes should be, and function calls should be minimized. It's been true for GPUs, for NICs, and for our example, disk I/O. And then the last bullet point is regarding, and so I think we wind up in the same place when dynamic operations proliferate more rapidly than types, we both use switches. When types proliferate more openly than operations, we both use dynamic dispatch. Again, I don't see how you got there. Obviously, types are proliferating more rapidly in this system, so that is true. If we didn't believe drivers are proliferating rapidly, why are we loading them dynamically? And I thought that was the entire point of the example. But perhaps more importantly, we are not using dynamic dispatch here in the way that you've been suggesting, as I was pointing out earlier. I said that when I proposed the design process, I would also do the inside drivers themselves. I would not duplicate drivers to remove if statements and switch statements inside a driver that allowed the driver to handle multiple similar devices. The only reason that there are function pointers in this system is because the problem definition required that we load the driver from a different module, and we are not presuming a JIT or something that can weld things together for us. That introduces a mandatory cut, so we cannot get rid of it because the problem is defined to contain it. But note that this is not the same between our two approaches. I have a function pointer there because it's required. And you'll note I minimized the number of all the way down to 1. I didn't put it in there because I think it saves program time. In fact, I'm not really sure I want it there at all. I haven't actually implemented this particular system in an OS, so it's somewhat off the top of my head. But it's very possible that if I actually went to write this, I wouldn't include that function pointer at all. Instead, I might just have the OS thread reading the queue. Sorry, the OS thread reading the queue and proliferating the, pre-filtering the packets for quota permissions, then updating a shared memory access that lets the driver know it can process the packets directly without actually implementing. I can't say that's for sure what I would do, but it's probably something I would try. So thanks for overstating the similarity of our approaches, but I think that they're similar, then I guess that's just where we end up. Thanks for taking the time to create this thread, which pushed the GitHub emoji checker well beyond its limits. Sorry, I had to read all that, but yeah, that was all right. So this is kind of the point I was trying to point out. So like Case was saying, this isn't what you were showing. And the point where I say, like, Mr. Martin thought he won the argument, like you need to use this style, is by using the canonical case of requiring it, which is the canonical case is a data stream. A canonical case of like, you've got different operations, fixed interface, but you've got opaque, different, what it actually variant type, whatever it is. And then they talk about actually how does it implement in the operating system. Casey actually just shows that actually effectively this is how you do it in Linux. We don't know how Windows works, kind of. You can reverse engineer it, but like it's not, the source code's not public, obviously, because it's a closed sourced operating system. But that's kind of the issue that's going on here. Mr. Martin thought he won by showing like, oh, you already just did dynamic dispatch. In case you went, you defined it to have it. And in fact, I didn't even require multiple functions. I required one. It's not triple indirect, it's only single indirection. And I just had a switch name in there because this is also how the operating system does it. And it's better for literally CPU cycles and reduced program cycles. It's not one or the other. So hopefully this is okay and I'm done now. I was just going to do this and I was talking about this. We've already discussed this, what I've been saying, but I did a tweet on it mildly. And there were some other things I was talking about here. I wanted to talk about Mr. Martin, but I didn't in the end, to be honest with you. It was more of a, I'm just showing the rhetoric styles of Mr. Martin. That was it. So I hope you've enjoyed this. I apologize, this is about 1 hour and 20 minutes long. So thank you for putting up with all this. I wanted to end off with this little thing here. This is what I wanted to end for. So we already had this in his code, but someone commented here saying, look, it says, but there's kinds of environments though, the parsimony is important, and nowadays far and few between. The vast majority of software requires less than 1% of modern processing, which is the first section we read. What's more, processors are so cheap and available that it is a trivial matter to add more of them to the system. Someone replied, I actually know this person, by the way, personally, we do not consider it good engineering practice, the person wrote it, not the quote, good engineering practice to consume a resource lavishly just because it happens to be cheap. Nicholas Viet, or Nicholas Worth, one of my actual programming idols out there. And I love this quote because it's Viet's law, Worth's law, however you want to pronounce his name. He doesn't care. It's either name by or bind value. It doesn't matter. And then Mr. Martin replies, that depends upon which resource you are talking about. Computer cycles, programmer cycles. Which should you trade against? And again, I don't see what would be in the odds, but simpler code is easier to write. Our bubble sort is simpler. The tricky, again, it's another trick. It was just last showing the rhetoric trick. Simple is actually an overloaded term in programming. And it's an overload term in English because simple can either mean the opposite of complicated or it can mean the opposite of complex. And in the case of complex, the technical term would be simplex. So is it simple as in not complicated or simple as in simplex? And he has just done this on purpose and he knows it very well by saying, well, bubble sort is simplex, but it's very expensive. Multiplying by repeated addition is simple. Actually, that's how like AMD processors, not AMD, ARM processors actually work. By the way, they don't technically implement multiplication. x86 does, by the way. ARM does. Oh, AMD 64. Sorry, I should say. AMD 64 does, and x86 in general. It's actually one of the only. It's very rare you find a processor that does this, but they did it. Linear searches are simple. Like, yeah, they are simplex. They also may be simpler, faster as well, but they might not be. Like, there's a reason. But this is the trick. So I just want to end on that note. So I hope you've enjoyed this. Please remember to like that smash button and to comment in the description below. And again, if you want to read any of these links before, I will post them in the description of the doobly-doo below here. And hopefully you've enjoyed this. This is very unstructured, ranty, talking about Mr. Martin's rhetoric style with regards to clean code. And at the end, effectively, he just stated exactly what most people thought clean code was stating. And Casey went, so I was right about what clean code was. Okay, thank you. So, goodbye everyone, and stay tuned for the next video.